Hello everyone. This video will show how to sketch a one-cycle graph of a cosecant function. In this example, we're given the function f of x equals negative cosecant of pi over 3 quantity x minus 1 plus 2. So the first step that we need to do is to determine the parameters. So our a here is negative 1. This represents as our amplitude. Our b is pi over 3. Our c is positive 1. And our d is positive 2. Now let's determine the midline. The equation of a midline is y equals the parameter d. In this case right here, our d value is 2. So the equation of the midline is y equals 2. The next step is to determine the phase shift. To determine the phase shift, all we need to do is to set this expression right here inside the parentheses equal to 0 and solve for x. So I'm going to show the work up here. We remember that this x value right here will represent the x coordinate of the starting point of a one cycle of the cosecant graph that we will be sketching in a little bit. The next step is to determine the period. The formula for period is 2 pi over b. So in this problem right here, our b is pi over 3. So we go ahead and say 2 pi divided by pi over 3. So we get a complex fraction. So we write down the 2 pi first. And then what we do is we flip the denominator and we multiply across. So this comes out 3 over pi. So that we can go ahead and cross out the pi and pi. So we are left with 6 for period. In order that we can sketch the cosecant graph, what we do is we will sketch the sine graph first, and then using that sine graph, we are going to sketch the cosecant from there. So we pretty much have to sketch the sine version of this equation. The reason why we're using sine here, it's because the reciprocal of sine is cosecant. So we can go ahead and sketch the graph. We're going to go ahead and set up our midline, which is located at y equals 2. Looking at our phase shift, it's located at x equals 1. So we go ahead and say this is our x equals 1 right here. And we remember that we're going to need 4 more points to create one cycle of cosecant graph. So I'm going to go ahead and sketch those points up here. This tells us that we're going to need these 5 points up on the midline as our reference to create the graph. Now let's determine the x coordinates for the rest of these points up here on the x-axis. To determine the values that we have here, all we need to do is from the phase shift or the starting point, we are going to add quarter of the period each time. So I'm going to go ahead and write that work down here. So it says here that from the phase shift x coordinate, that means from this point right here, which means that our starting point, we're going to add quarter of a period every time. So in this case right here, our period is 6, and then we divide that by 4. The reason why this is 4, because we have 4 more dots that we need to figure out its coordinates. 1, 2, 3, 4. So this can be reduced to 3 halves. So what we do is we're going to add 3 halves each time to get the values for the rest of these. Now, if you notice, we have a 1 here, and then if we add 3 halves to it, they will not have the same denominator. So I'm going to go ahead and multiply this by 2 over 2, and that would come out 2 over 2. Now, we're going to be adding 3 over 2 each time, so that would be 2 over 2 plus 3 over 2 is 5 halves. Next, 5 halves plus 3 halves would be 8 halves. 8 halves plus 3 halves would be 11 halves. And 11 halves plus 3 halves would be 14 over 2. From here, we can go ahead and reduce to lowest term those fractions that can be reduced to lowest term. From here, we can go ahead and sketch our sine graph. Since this is negative and our amplitude is 1, so that means we're going to go down 1 and we create our sine graph. We also have to go up 1 and sketch the graph. Now we remember that the point from the sine graph that touches the midline in a cosecant graph, this will be a vertical asymptote. So there is a vertical asymptote down here. Another vertical asymptote would also be here since our sine graph touches the midline. And there is also another vertical asymptote down here. So vertical asymptotes for cosecant graph exist when the sine graph touches the midline. Now we're ready to sketch the cosecant graph. Now we remember that the minimum of the sine graph is actually the maximum of the cosecant graph. So that means our cosecant graph would start from here and it's going to go to the asymptote. On the other hand, the maximum of the sine graph is the minimum of the cosecant graph. The one in red is the graph of negative cosecant pi over 3x minus 1 plus 2. So this sine graph that I use as broken line is just a guide so that we can sketch the cosecant graph. So we can go ahead and delete this sine graph here. So this is one period or one cycle of this function that we have up there. Please remember that we can add more periods to the left or more periods to the right. But for this example, we're only asked to draw or sketch the graph of one cycle of this function up there.